You can build better classification and prediction models using Ensemble methods in XLMiner platform. In this video, you will see how to classify wine samples using the classification tree boosting ensemble method. An ensemble is a technique for combining multiple weak learners in an attempt to create a strong learner by taking a weighted vote of their individual classifications or predictions. In this example, a weak learner is a classification tree. Here is the data set with information about wine, including 13 variables that describe various properties of wine from 3 different vineyards. The goal is to assign a wine classification to each record. Select a cell within the data, click on Classify, Classification Tree. Now choose Boosting. Select Type as our output variable. This is the wine type which we are going to assign to each of the records. Select all the remaining variables as our selected variable. Now click on Next. Leave the default selection for boosting algorithm, AutoBoost M1. XLMiner offers 3 different variations of boosting algorithms. The difference in the algorithms is the way in which the weights assigned to each observation or record are updated. Let's leave the number of weak learners as the default value of 50. This will tell XLMiner to construct 50 different classification trees during the run, train each one on different subsets of data, and combine the results to get a better classification. Use resampling is selected by default. This means AutoBoost algorithm chooses a sample of records in each iteration and assigns higher probabilities to misclassified records so that those records are favored in the next sample selection. In the trees section, leave the defaults of levels and 7 for maximum number of 3. The tree may also be limited by the number of splits or nodes by choosing this drop-down menu. Let's keep the default option of 17 for minimum number of records in a terminal node. XLMiner stops splitting the tree when all nodes contain a minimum of 17 records. Let's check this box to partition the data. Accept all the default settings and click on Finish. Here is the output of the classification tree boosting algorithm. Let's click on Ensemble Details in the Output Navigator section. As you can see, XLMiner assigns a weight to each of the 50 weak learners. The importance percentage for each variable measures the variable's contribution in reducing the total misclassification error. Let's scroll down to Training Data Scoring Summary Report to view the classification confusion matrix. The confusion matrix displays counts for cases that were correctly and incorrectly classified in the training and validation datasets. No records were misclassified in the training dataset, and only 2 records were misclassified in the validation data, resulting in a % error of 2.8. Now let's compare the ensemble boosting method results with those from a single tree. Click on Data tab, select a cell within the data, click on Classify, Classification Tree, this time choose Single Tree. XLMiner automatically recalls and repeats the selected variables. Let's click on Next. Let's accept the maximum number of tree levels. Minimum number of records in a terminal node is selected by default. Let's check this box to partition the data. Now accept all the remaining default settings and click on Finish. Here is the output of the classification tree algorithm. Let's click on Train Score Summary Report. Here is the confusion matrix. There was one case misclassified in the training data, resulting in a % error of 0.93. Let's scroll down to Validation Data Scoring Summary Report. There were 8 cases misclassified in the validation data, resulting in a % error of 11.27. As we just saw, classification tree ensemble methods are more powerful than a single tree and typically result in better performance.